Now I'm going to talk to you about the ionic compounds. Remember, there are three types of compounds we're going to talk about here. And so remember I told you to determine which type you're working with, always look at the first element. If the first element is a metal, then we're going to focus on the ionic, which we're going to talk about now, and therefore we're working with charges. If the first element is a nonmetal, then you're dealing with covalent, also called molecular. If the first element is a hydrogen, then you're working with an acid. But I'm going to talk to you about the ionic. We call it binary ionic and ternary ionic. The fact is, it's just ionic, and there'll be a metal bound with a nonmetal. We also call this a cation bound with an anion, or a positive charge bound with a negative charge. Now, why does a metal become positive and a nonmetal become negative? Well, there's a transfer of the electron, because in this process, they want to become like a noble gas, and they want to acquire a full octet so they can reach a point of stability. The nice thing about this is once you memorize these cations and you bring them together in the correct ratio, all you have to do is simple elementary math and make sure that the positive number plus the negative number equals 0. Because we always know the answer has to be 0 because the compound, the ionic compound, must be neutral. The first example I'm going to give you right now is sodium chlorine. Sodium and chlorine. Sodium is in group 1, has 1 valence electron. Chlorine is in group 17, has 7 valence electrons. Now I'm taking a step back here. Now my sodium, remember, says, you know what, I want to get rid of this 1 valence electron, and chlorine says I want to gain it. So a transfer of electrons occurs. Now we're assuming this already happened because I have you memorizing sodium as a +1 and chloride as a -1. So I'm assuming this has already happened. And all I'm asking you to do is bring sodium and chloride together in the correct ratio now so the charges add up to 0. And if you do so, you're just dealing with simple math. So once you know the charges, then you do an elementary math. I have a positive 1 plus a negative 1. Does that equal 0? Is this statement true? Yes, it is. So that means all I need is 1 Na and 1 Cl. Remember, the metal is already written first. So again, you see, just memorize the charges, and then to bring them together in the correct ratio, all you're dealing with was simple elementary math. Now when you deal with charges, sometimes it's easier just to use what we call a crisscross method. And for example, with the crisscross method, all we do is bring the number of the charge down as a subscript. And this keeps us, I call it the no-brainer method, because it keeps you from thinking and having to do elementary math. So in this situation, I'll bring the 3 from the aluminum down for the oxide and the 2 from my oxide down for the aluminum. So my correct ratio is Al2O3. Now you do want to double check your work and you make sure that you did it correctly. So I realize I have 3 aluminums. Each aluminum comes in at a +3. Plus I have 3 oxides. Each oxide coming in as a -2. Now how do you know +2, -3, -2? +3, -2? You memorize it. It's what I gave you to memorize. And so you realize, oh, it's a +6 plus a -6 equals 0. That statement is true. I have the correct ratio. Now one thing you have to be careful about the crisscross method, when you do bring down the crisscross method and you check it and you realize, oh, it's a +2, -2, you realize I just have to bring them together in the 1-to-1 ratio. If you do the crisscross method and you end up with a 2-to-2 ratio, remember what I said in statement 3 up above, they must be in the lowest whole number ratio. So you must simplify it down to CaO. Now, examples of these binary. Now remember, on the test, half the test is going to be, I give you the formula, you write out the name. The other half, I give you the name, you write out the formula. So let's go from formula to name. So first of all, we look at the first element. And guess what? It's a metal, aluminum, calcium, they're metals. So I realize I'm dealing with ionic compounds. And with this, aluminum and oxygen. When I name an ionic compound, all I do is name the metal and change the nonmetal ending to IDE. So aluminum oxide and calcium oxide. Now the only time that ionic compounds require a little extra work is when they have one of our 7 transition metals. And why they require a little extra work is because our 7 transition metals can have more than one charge. For example, I see the compound starts out with iron. I know it's an ionic compound. So I say iron oxide. Now you're not 100% wrong, but you're not 100% right. What you have to realize here is that iron is one of your transition metals. So you realize that iron can be a +2 or a +3. So in this situation, you have to look at your oxide, and we do some simple elementary math. So in this situation, I realize I have 2 irons. I do not know what its charge is, but I have 3 oxides, and each oxide is a -2, so it adds up to a -6. So whatever I have plus -6 must equal 0. Well, I know I have to have a +6. And I realize in my ratio, I have 2 irons. So 2 irons must add up to a +6. Therefore, each of them is a +3. So then I realize, oh, it's a +6 plus a -6 equals 0. So yes, I am dealing with a iron 3 to give me the correct ratio. I can also carry out some pre-algebra. If you want to do this, you don't need to, but pre-algebra says I have 2 irons, X, I do not know its charge, plus I have 3 oxides, I know oxide is a -2, and I know that they added together must equal 0. Do this pre-algebra, you'd come up with 3 the exact same way. So we call it iron 3. Now the common name, I do expect you to be familiar with it. 3 is the higher of the 2 charges for iron, therefore it is ferric. Remember, ic goes with the higher of the 2 charges, us goes with the lower. So iron 2 is ferrous. Now, going from name the formula. Going to name the formula, I mentioned this to help you keep you from making mistakes. Always identify the element and its charge. So beryllium is Be, it's in column 2, it's a +2. Fluoride, that's for fluorine, it's in column 17, and that's a -1. Now you just do simple elementary math. Well, I have a beryllium +2 plus a -1 equals 0. Is that statement true? No, it's not. What do you need to do? You need 2 of your fluorides. And then you know that +2 plus -2 equals 0. Then it makes the statement true. So if I need 2 fluorides, then I just put a subscript 2. BeF2. I need 2 of them. The last thing you need to remember about polyatomic ions, we're going to go to ternary. And ternary is when these transition metal, or these polyatomic ions, come into play. And with the polyatomic ion, we have more than one element that has a set name and a set charge. Like we saw with cyanide, ammonium hydroxide, they are more than one element and have a set charge. So what you must remember with these, when you need more than one of them, and when you need only more than one of them, that's the only time you put parentheses around them. Because you're specifying you need more of one of them as a unit. They come together as a unit. Do not separate out the unit. So this gives us an example right away. We see our polyatomic ion, nitrate, had to be put in parentheses in this situation. Well, we call these ternary. The only reason why we call it ternary now is because we have more than 3 elements involved in the process. It's still an anionic compound. I have a metal and a nonmetal, or a cation and an anion. So I see my iron is my metal, so I know it's an anionic compound. And I realize the ratio is 1 iron to every 3 nitrates. Now I realize, okay, it is iron nitrate, but you pause yourself and you say, okay, iron can have more than one charge. Is it a 2 or is it a 3? And you have to memorize that. And so you realize, well, I needed 3 nitrates to zero out my 1 iron. Each nitrate comes in at a -1. So that means I have a total of -3. Therefore, my 1 iron must be a +3. Then I have +3 plus a -3 equals 0. Now my simple arithmetic. There's your simple elementary math. Once you memorize the charges, the rest is just arithmetic. And you realize, oh, okay, my iron therefore must be a +3 in this situation. Well, the common name, 3 is the higher of the 2 charges for iron. Remember, it is ferric. Now also you'll go from name to formula. Again, always know the charges. Potassium's in group 1, it's a +1. Thiocyanate, you just had to memorize it, is SCN with a -1. I have a +1 plus a -1 equals 0. Is that statement true? Yes, it is. Therefore, I bring them together in a 1-to-1 ratio. It's a K SCN. Now you could do the crisscross method here and just drop the 1's down, but that's even more thinking than actually doing the simple arithmetic. Next one, cobalt 3. So cobalt, I know, is a +3. My Roman numeral tells me that. That's the nice part about the IUPAC name. Oxalate, you just have to memorize it. It's C2O42-. Now in this situation, this is where the crisscross method is helpful. Just drop the 2 down for your cobalt and the 3 down for your oxalate. And remember, I need 3 oxalates. So what must I put around my oxalate, my polyatomic ion, to protect it? Because it's a unit, correct. You must put parentheses around it. You need 3 of them. The next one we talk about are hydrates. Hydrates are just ionic compounds that have water molecules trapped inside the crystal. So we look at it, we just name the ionic compound. I mean, this is the first time you could use prefixes. You just tell me how many waters are present. For example, Zn, it's a metal, so you know it's your ionic compound. It has water trapped in it. It's a hydrate. So you say zinc, name the metal, name the nonmetal. Zinc sulfate. Next, 7, prefix for that is hepta. Water, we call it hydrate. So it's heptahydrate. Next, also go from name to formula. Well, name to formula, again, first of all, do the ionic compound. Calcium's in group 2, it's a 2 plus. Chloride's in group 17, it's a -1. A positive 2 plus -1, does that equal 0? No. I need 2 -1s. So my formula is CaCl2 dot, and then what's the prefix, what's the number for penta? 5, and then hydrate is water, so 5 waters.